Hello.
Yes, ma'am.
Okay. I'm just opening your syllabus. Um, because most of topics we have with the software. mm, or PSPP. Okay. So from the next session, we'll start all topics of this. And today, shall we do week two, in which we
Yes, ma'am.
have,
We can start that.
yeah, view of Pearson correlation coefficient and type 1 and type 2 errors. Okay. So shall we do correlation coefficient?
Yes, ma'am.
One. Pearson correlation coefficient. Correlation coefficient. Let x and y are two variables. Then correlation coefficient is denoted by r, and this is equal to n into summation xy minus summation x into summation y over n summation x square minus summation x whole square n into summation y square minus summation y whole square. This is formula to find correlation coefficient. So let us do one example. I'm sending you this question. Uh, I'm sending you this question and then I'm going to tell you on whiteboard also. We have x and we have y, and we need of x square, x and y, x square, y square, and xy. X, y, x square, y square, and xy. So 12, 15, 18, 15, 18, 21, 27. 2, 4, 6, 8, 12. X square, or let us find it. X square 144 and 225. Square of 15. Square of 18 is 324. Square of 21 is 441. And square of 27 is 729. And summation x is equal to 93. Summation y is equal to 32. Summation x square, we have 1863. And summation y square, we have square of 2 is 4, 16, 36, 64, and 144 we have. And summation y square is equal to 264. And x and y, 24, x into y, and 60, 15 into 4, 18 into 6, 94. Oh, no, this is 3rd value is 168 and 27 into 12, 324, and summation x into y is, I'm just checking, sum of each 12 plus 15 plus 18 plus 21 plus 27, we have 93, and 2 plus 4 plus 6 plus 8 plus 12, 32, and 144 plus 225 plus 324 plus 441 plus 729. We are 1863, and y square, we have 4 plus 16 plus 36 plus 64 plus 144. 264, yes, we have. Now 24 plus 60 plus 108 plus 168 plus 324. We have 684. We have this. And now we need to find correlation coefficient by using these values. And here n is equal to, we have 1, 2, 3, 4, 5. We have 5 values, so we have n is equal to 5. And now let us find correlation coefficient r is equal to n into summation x into y minus summation x into summation y over some n into summation x square minus summation x whole square into n into summation y square minus summation y whole square. We have this. N is 5, and value of summation x into y is 684. So 684 minus summation x is 93, and summation y is 32, and some n is 5, and summation x square is 1863. So this is 1863 minus square of 93, 5 into summation y square. Summation y square is 264 minus summation y whole square. So summation y is 32. So let us square. So now simplify. 5 into 684 minus 93 into 32. So we have this difference. This is 3420 minus 93 into 32. So we have this 2976, and we have 5 into 1863. So we have 9315 minus 93 square is 8649 into 5 into 264. This is 1320 minus 32 square, 1024. Now let us simplify this calculation. So 3420 minus 2976. We have numerator 444, and denominator, let us see, And 9,315 minus 8,649. We have triple six means 666. 296. So let us simplify 444. I'm just checking the calculation. Just give me a few seconds. Give me a few seconds. I'm just checking it. 1 minus 3. Just a second. In formula, we have square root also. Square root of this denominator. We have square root of this denominator. So now we have square root of these values. So product of 666 into 296, we have 197,136. We have this. So now let us find square root. Square root of 197,136. Yes, we have 444 only. Square root of this value. So we have correlation coefficient 1. Now I'm telling you correlation coefficient range. The correlation coefficient ranges from -1 to 1 only. Means we'll always find value of correlation coefficient between -1 to 1. It cannot be less than -1 and cannot be more than 1. You got it?
Yes, ma'am.
Okay. Just looking the next topic. I'm just opening the next topic. Give me a few seconds. Uh, in week 2, we have done this correlation coefficient, and other topics are of theory. Okay. So I'm checking in another in week first. Obviously, we have theoretical portion, and in second, we have only this Pearson correlation coefficient, only numerical based, and other there are of theory. And third week, we have topics based on software, and fourth and fifth we have done already, and sixth also. And that day we have done multiple regression. I'm telling you once more, regression lines. Okay, even we have done last time, but now we have, so I'm going to review it again. Later we'll do these all in that software PSPP. Okay, because after that we'll have only topics related to that, so we'll practice on that. Okay, so I'm telling you, regression lines. You can say regression line or linear regression to them. So we have two equations, regression equation. Now, first we have regression equation of y on x. This is y is equal to a plus bx. And I'm going to tell you what are the a and b. And regression equation, second equation of line, or regression equation of x on y is x is equal to a plus b y. Now let us know how can we find these a and b. Or how can we write this equation in another form? Y, first I can tell you about A and B, then I'll okay, another form will take time to do. Okay, even I'll tell you. But first, I'm telling you value of A and B here. And where A is equal to, if we have data, then we find a value of A and B, then we can find regression line or linear regression. A is equal to summation y into summation x square minus summation x into summation xy over n into summation x square minus summation x whole square, and b is equal to n into summation x and y minus summation x into summation y over n into summation y square minus summation x square. If we have data, then we can find value of a and b, and we can put here to find regression equation of y on x and x on y. Okay. Or in another way, how can we find the equation? I'm telling you. Or you can find, if you have like mean or of both, and standard deviation and correlation coefficient. In that condition, they'll give you direct values. Then you can find regression equation of line of y on x, y minus y bar is equal to r correlation coefficient into um, standard deviation of x over standard deviation of y into x minus x bar. If we have these values x bar, y bar, and these all three, then we can find by using this formula. If we have data, then we can use these formula. Most probably you will find by using previous formula, but if you have all values directly, then you can use this one also. And regression equation of x on y is x minus x bar is equal to r into uh, sigma x over sigma y into y minus y bar. So let us do one example for a regression line. Usually we use previous formula. So I'm sending you question. Sorry, I forgot to write here. For y on x, we write y first and x later. And for equation of x on y, we have this one. So let us do one question to understand this well. I'm just sending you question first. I send you questions, so just check it. Can you find these equation by using this data? By using data, you can find like these values of A and B. You need to find. Just construct table as before we have done already. See in this case, because we need summation x, summation y, summation x square, summation y square, even summation x into y. We need it. So construct a table for the given data as such, and then you can find value of a and b. Then just put in these equation. Then you can find required linear regression or regression equation in both condition. So can you do that?
Yes, ma'am.
Just try it, or if you want, then I'll send you more questions related to these topics. And from the next session, we'll do software based topic, because we have only those topics and also theoretical. So I'll send you related notes, theoretical notes. Even you have, I'll explain you. Even we have done already, or most of those topics of theoretical. I'll explain you by using them, or if you want again, then I'll send you. Okay, okay. Or by next time, or if you have that software, then it's okay. Otherwise, you can download and install that, and we'll do that. Okay.
Okay, ma'am.
All right. So just practice these questions. Example second, I have sent you. Even we have done, but do yourself and this question also. Okay, is it okay with you? So
Yes, ma'am.
we'll do on Sunday, because for software we need a little bit more time. So okay, let's do surely on Sunday. Okay.
Okay, ma'am. All right, ma'am.